Good morning, ladies and gentlemen. Today we are on page 67 of your student journal, and our objective or our goal today is I will decompose fractions. And our main word is decompose. That's a new word that we have not talked about yet. So let's look at our vocabulary. Our first vocabulary word is letting us know what a numerator is. So it's the number of equal parts being considered. That's the top number of our fraction. Sometimes I like to think about it's also usually what you have if they're talking about something shaded, or if they're talking sometimes in a word problem about a food item, but it's how many pieces you have or parts you have. The denominator is the total number of equal parts in the whole. So it's how many parts has the whole been partitioned into. So for example, this means that the whole was partitioned into 4 parts and I have one of the 4 parts. So if this was pizza, this would mean the pizza was cut into 4 slices, but I only have one of them. Okay, our main word today, oops, my pen is leaking. Our main word today is decompose. So decompose means to break a fraction into smaller parts. So to break a fraction into smaller parts. So our 2 examples here are 5/6 is equal to 2/6 plus 3/6. So if you notice when they broke this up, they only break up the numerator. The denominator always stayed the same. So I also could break up 5/6 into 1/6 plus 1/6 plus 2/6 plus 1/6. So again, the denominator is always 6, but the numerator of 5 was decomposed or broken up into 1, 1, 2, and 1, because when I say 1 plus 1 plus 2 plus 1, I end up with a 5. So when you decompose fractions, you only decompose the numerator. Okay, our steps today, I'm going to let you use them if you need them, but I'm just going to show you this because I think our steps are really long to have to remember. And I think when you see it, it will make more sense. Okay, so my first problem says, illustrate 2 ways to decompose 4/9. Okay, so I'm going to actually use an area model for this one. So I'm first going to draw it. So what does 4/9 look like? Well, 9, a denominator of 9 tells me that my whole was partitioned into ninths. So I'm going to partition it into thirds first and then cut these up. So, and then the 4, the numerator 4 tells me I have 4 of them. So I have 1/9, 1/9, 1/9, and 1/9. I only have these 4. So one way that I could decompose this 4/9 is I could break it right here. So I could say I have those 2/9 plus I have these 2/9, and that equals 4/9. So again, my denominator of 9 stayed the same, but my numerator of 4, I decomposed or broke it up into 2 plus 2. Okay, I also could have done it differently. Let me draw it again. And I have 4/9. So this is what I have. So instead of decomposing it right there in the middle, I could have decomposed it here. And I could have said I have 1, 2, 3/9 plus 1/9 equals 4/9. So again, my numerator of 4 was what I decomposed or broke up into the 3 plus 1. Okay, on number 2, I'm going to show you the same thing with a number line. So they've already created my number line for me, and the number line has been divided into 1, 2, 3, 4, 5, 6 parts because my denominator is 6. I'm going to label these 1/6, 2/6, 3/6, 4/6, 5, 6, and 6, 6. Okay, so they've already decomposed my numerator of 5 into 1 plus 1 plus 1 plus 2, but they want me to show this. Okay, so they did 1, and then they added another 1. Oh, I should have left my red pen, I apologize. And then they added, let's see, so they added 1, they added another 1, now they added another 1, and then they added 2, so they jumped 2. And look where they end up, at 5, 6. So I still get 5, 6, just depending on how I broke up how I got there. Okay, let's try some together. So we're on page 68, and here's our first one. And it says, illustrate 2 ways to decompose 5, 6. So we're going to do this using a area model. Okay, and remember you're going to have to do it 2 ways, so you want to leave some space. You don't want to do it too big. Okay, so here's my first one. And I'm going to divide it in half, and then if I divide those into thirds, that should give me 6 parts. So we have 5 out of the 6 parts. So we have 1, 2, 3, 4. We have 5 of the pieces. That's what we have. That's what 5, 6 looks like. So they want us to decompose it. Now, on my example, I had only decomposed it into 2 numbers, to 2 fractions. You could decompose it in a multiple like they did here. Here they decomposed it into 4 fractions. So it's really up to you. Maybe for this one, we'll just decompose it into 2. So we can break it right here. So we can say I have 1, 2, 6 plus 1, 2, 3. 3, 6 equals 5, 6. Okay, let's try it a different way on the next one. So let's draw our 5, 6. And we have 1, 2, 3, 4, 5 of the pieces. And maybe let's break this one up or decompose it into 3 times. So we could, let's do maybe here and there. So what do we have? We have over here, we have 1, 2, 6, plus here we have 1, 2, 6, plus here we only have 1, 6. And that equals 5, 6 total. Okay, let's look at our second problem. It says, use a number line to show that 5 tenths equals 3 tenths plus 1 tenth plus 1 tenth. Okay, and they've already drawn our number line, and it should be partitioned into 10 parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's label them. 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, and 9 tenths, and then 1 is equivalent to 10 tenths. Okay, so they want us to start with 3 tenths. So we're going to start at 0 and we're going to go to 3 tenths. Then they want us to add just 1, and then they want us just to add 1 more. And we ended up at 5 tenths. Okay, so ladies and gentlemen, you have the next 3 pages to try on your own. Have a nice afternoon.